The area enclosed by the curves y is equal to x power 3 and y is equal to square root of x. So y is equal to square root of x, we can also write y square is equal to x, a parabola. So let us sketch the graph. And here we need to consider x must be positive. So which implies that y also must be considered positive. So the graph of this y is equal to root x, y square is equal to x parabola, we have to take the only on the positive side direction of y axis and x axis. So we can see this is y square is equal to x graph. Since x is positive only, we need to consider y positive. And y is equal to x power 3 graph, we can see that so here we can say y is equal to x power 3, and we can observe that the area formed between these two curves is here. So we need to identify the point of intersection. One point is clearly we can say 0 comma 0, and another point we need to identify. So let us substitute x is equal to y square here. So solving these two equations, y is equal to x power 3 and y is equal to x is nothing but y square whole power 3. So we can add y is equal to y power 6, or y power 6 minus y is equal to 0. So y taken common, so y power 5 minus 1 is equal to 0. So we can say y is equal to 0 and y power 5 is equal to 1. So one of the real root we can take y is equal to 1. So let's assume that this is y value 1. So when y is equal to 1, which implies x is equal to x is also equals to 1. So here is the point 1 comma 1, means x coordinate is 1. So we can say the area, required area is equal to integral 0 to 1, the upper curve that is y is equal to root x minus the lower curve that is x to the power of 3 dx. So you can simplify and write integration of root x is x to the power of 1 by 2 plus 1, that is 3 upon 2, 3 by 2 divided by 3 by 2 minus integration of x power 3 is x to the power of 4 divided by 4 over the limit 0 to 1. So we can write 1 upon 3 by 2, that is 2 by 3, minus 1 upon 4, so which is equal to 2 upon 3 minus 1 by 4. So 8 minus 3, 5 upon 12. So 5 by 12 can be the answer, which is option C. So the required area is 5 by 12 square units. We need to find the area under the curve y is equal to mod of cos x minus sin x. So in the interval 0 to pi by 2. So let us see the graph of cos x and sin x in the interval 0 to pi by 2. Let's take the sin x graph. Say here this is pi by 2 and say here it is 1, and cos x will come. Cos x graph can be taken as So we can see the graph here. This is cos x and here is a sin x, and 0 to pi by 2. In 0 to pi by 2 we can check that the area under the curve y is equal to cos x minus sin x. So cos x minus sin x from 0 to pi by 4, here it is pi by 4. Both values are 1 upon root 2. Cos and sin both are same. X is equal to pi by 4, and here we can say that 0 to pi by 4. In 0 to pi by 4 the graph is cos x is greater than sin x, and again pi by 4 to pi by 2. Pi by 4 to pi by 2 we can see that the graph is where sin x is greater than cos x. So we can write the interval here, required area, which is equal to 0 to pi by 4 cos x minus sin x, and again dx, plus integral pi by 4 to pi by 2 sin x minus cos x, because in the interval pi by 4 to pi by 2, so we can see that sin x is greater. Or this can also be written, required area is equal to 2 times integral 0 to pi by 4 cos x minus sin x dx, because here we can see that these are two symmetrical portions. So the area formed here and here will be the same. So we can also do like this. So let us find here, integration of cos x is minus sin x, sorry, plus sin x, and integration of sin x is minus cos x, so plus cos x over the limit 0 to pi by 4. And here we can see integration of sin x is minus cos x, and integration of cos x is sin x over the limits pi by 4 to pi by 2. So applying the upper limit here, sin pi by 4 plus cos pi by 4 minus lower limit sin 0 plus cos 0, and again here we can write minus cos pi by 2 minus sin pi by 2 minus lower limit, means plus you will get cos pi by 4 plus sin pi by 4. So cos pi by 4 plus cos pi by 4, that is 2 times of cos pi by 4 is 1 by root 2, and again sin pi by 4 plus sin pi by 4, that is 2 times of 1 by root 2, and sin 0 value is 0, cos 0 is 1, and cos pi by 2 is 0, and again sin pi by 2 is 1, so minus 1 we can write. So 2 upon root 2 plus 2 upon root 2 is 4 upon root 2, minus 1 is minus 2. So we can add 4 into root 2 divided by root 2 into root 2 minus 2, that is root 2 into root 2 is 2, 2 times, so 2 root 2 minus 2 square units. So we can go with an option, the required area is 2 root 2 minus 2 square units, option B. And even if we can do by the second method, so in 2 times integration of cos x is minus plus sin x, and integration of sin x is minus cos x, so plus cos x, so over the limit 0 to pi by 4, that is 2 times of sin pi by 4 plus cos pi by 4 is 1 by root 2 plus 1 by root 2, that is 2 by root 2, minus sin 0 is 0 and cos 0 is 1. So here we can write 2 into 2, 4 upon root 2 minus 2, same as this value, so we can say 2 root 2 minus 2 is the answer. Let the straight line x is equal to b divide the area enclosed by y is equal to 1 minus x whole square, y is equal to 0 and x is equal to 0 into two parts, R1 and R2 from 0 to b and b to 1, such that R1 minus R2 is 1 upon 4. Then we need to find the value of b. Let us see the graph of 1 minus x whole square. Y is equal to 1 minus x whole square. We can also write it as x minus 1 whole square. At x is equal to 1, you will be getting y0. So that is a minimum vertex of the parabola, we can say. So we can see the graph. Y is equal to x minus 1 whole square. And since it is given R1 from 0 to b and b to R2 is b to 1, so b will be lying between 0 and 1. So let us consider b is here. From 0 to b, there is one region, and again from b to 1 and b to 1 is another region. Say this is R1 and R2, and the difference between R1 and R2 is 1 upon 4. So let us identify what is R1. R1 area is, so this is equation x-axis y is equal to 0 and y-axis equation is x is equal to 0. So y is equal to 0, x is equal to 0, and the graph integral, we can say 0 to b 1 x minus 1 whole square dx, which is equal to x minus 1 whole power 3 upon 3 divided over the limits 0 to b, that is b minus 1 whole power 3 upon 3 minus 0 minus 1 0 minus 1 whole power 3, that is negative of negative 1 plus 1 by 3. And now R2 area is equal to integral b to 1 x minus 1 whole power 3 upon 3, which is equal to, so we can write x minus 1 whole to the power of, sorry, this is x minus 1 whole square. So we can write x minus 1 whole power 3 upon 3 over the limits b to 1, which is equal to 1 minus 1 0 upon 3, 0 minus b minus 1 whole power 3 upon 3. And now R1 minus R2 is equal to 1 upon 4. We can write b minus 1 whole power 3 upon 3 plus 1 by 3 minus of minus plus b minus 1 whole power 3 upon 3 is equal to 1 by 4. That is 2 times of b minus 1 whole power 3 upon 3 is equal to 1 by 4 minus 1 by 3. So we can write 2 times of b minus 1 whole power 3 upon 3 is equal to 3 minus 4, that is negative 1 upon 12. So we can write b minus 1 whole power 3 is equal to minus 3 by 12 into 2. So we can write negative 1 by 8. So b minus 1 whole power 3 is equal to minus 1 by 2 whole power 3 we can write. So b minus 1 we can write it as negative 1 by 2. So which implies b is equal to 1 minus half. So b is equal to 1 minus half is half. So the value of b we can consider to be 1 by 2, which is option B. So option B is the answer. We need to find the area of the region R is equal to capital X comma Y such that mod x is less than or equals to mod y and x square plus y square is less than or equals to 1. X square plus y square is equal to 1 represents a circle with a radius 1 unit and center it 0, 0 comma 0. So we can take 1 unit radius and we can draw the circle. And also mod x is less than or equals to mod y. So which is representing like x is equal to y line and y is equal to x is equal to minus y line. So this x is equal to y and x is equal to minus y line. And since it is given mod x is less than or equals to mod y, so we will be getting the region so which is interior of the circle. So we can say the common region is this. So we can find, let us find the point of intersection of these 4 points, say A, B, C and D. Substituting x is equal to y in the given circle equation, x square plus x square is equal to 1, which implies 2x square is equal to 1. So x square is equal to 1 by 2. So x is equal to plus or minus 1 by root 2. So we can say here it is x coordinate is 1 by root 2. And when x is equal to 1 by root 2, so we can say y value also 1 by root 2. And similarly here, x coordinate will be 1 by root 2 and y coordinate will be negative y. So minus 1 by root 2. And even here we can consider x is equal to negative 1 by root 2. So minus 1 by root 2 and plus 1 by root 2, we can take the point minus 1 by root 2 and plus 1 by root 2. And the point C here, we can say both are negative, minus 1 by root 2, minus 1 by root 2. So this is how we got the 4 coordinates, the point of intersection. So we can say from 0 to 1 by root 2. So here we can say the upper curve is x square plus y square is equal to 1. We can write it as x square plus y square is equal to 1. So y square is equal to under root of y square is equal to 1 minus x square. So y is equal to under root of 1 minus x square. So we can write the area, required area is equal to, and here we can also consider this is the 4 times, all are symmetrical portions. So 1, 2, 3, 4. So we can write 4 times integral 0 to 1 by root 2. Upper curve is root of 1 minus x square minus lower curve will be y is equal to x, the whole dx. So let us integrate 4 times integration of root of a square minus x square. So I can write here integral root of a square minus x square dx is equal to x upon 2 root of a square minus x square plus a upon 2 sine inverse of x plus c. So we can write here x upon 2 under root of 1 minus x square plus a upon 2 sine inverse of x, and integration of x is x square upon 2 over the limit 0 to 1 by root 2. So substituting here, so 4 times 1 by 2 into 1 upon root 2 into under root of 1 minus 1 by root 2 whole square is 1 by 2 plus 1 by 2 sine inverse of 1 by root 2 minus 1 by root 2 whole square is 1 by 2 divided by 2, and here we can see it is 0. Lower part will be 0. So here 2 times 2 upon root 2 is root 2. Root 2 into under root of 2 minus 1, that is 1 by root 2 plus 1 by 2 into sine inverse of 1 by root 2 is pi by 4 minus 1 by 4. So we can just consider here. So 1 minus 1 by 4 is 3 by 4. 3 by 4 plus pi by 8. So 3 by 4 plus pi by 8 is the area here. Sorry, here 4 times you should write 4 by 2, and here it is. So it is 4 upon 4 is 1, and 1 minus 1 is 0, and here it is 4 by 2, that is 2 of pi by 2 will get. So we can write 1 plus pi by 2 minus 1. So we can go with an option pi by 2, which is option C. So the area enclosed by mod x less than or equals to mod y, and x square plus y square less than or equals to 1 means interior of the circle. The answer is pi by 2. The area bounded by the x-axis and the curve y is equal to f of x, and the lines x is equal to 1 and x is equal to b, where it is given b is greater than 1. So the area formed or enclosed between this can be represented by integral 1 to b f of x dx, and which is given by root of b square plus 1 minus root 2. So differentiating with respect to b, so we can write by using the Leibniz rule, f of b into differentiation of b is 1 minus f of 1 into differentiation of 1 is 0 is equal to 1 by 2 root of b square plus 1 into differentiating to b square plus 1 is 2b minus 0. That is f of b is equal to, so we can write b upon root of b square plus 1. So we can also say f of x is equal to x upon root of x square plus 1, so which is option D. So we can go with an option D. We need to find the area intercepted by the curves y is equal to cos x and y is equal to cos 2x in 0 to 2 pi. Sorry, 0 to pi. Let's see the graph of cos x. Cos pi by 2 is 0 and cos pi is 1, negative 1, sorry. This is cos y is equal to cos x in 0 to pi, and again now cos 2x, when x is equal to 0 cos 0 is 1, when x is equal to pi by 4 cos pi by 2 that is 0, and when x is equal to pi by 2 it is cos pi is negative 1, and again for 2 pi by 3 we can see that cos pi and cos 2 pi by 3 both are same, and again for cos pi it is equals to when x is equal to pi cos 2 pi, which is equal to plus 1. And here we can see that these two curves are intersecting at the 2 points. So here A and B. So here the B point whose x coordinate is 2 pi by 3. So we can say the shaded region or the required region are intercepted between these two curves. So required area is equal to integral 0 to 2 pi by 3. Upper part is the cos x graph minus the lower part is the cos 2x graph dx. So we can write integration of cos x is sin x, integration of cos 2x is sin 2x upon 2 over the limits 0 to 2 pi by 3. So we can write sine 2 pi by 3 minus sine 4 pi by 3 divided by 2, and again the lower limit will be 0. So sine 2 pi by 3 is sine pi minus pi by 3, and again 1 by 2 times of sine pi plus pi by 3 is 4 pi by 3. So sine pi minus theta is sine theta, so sine pi by 3, and again minus 1 by 2 sine pi plus pi by 3 is sine pi by 3 minus, is negative of negative plus, so sine pi by 3 is root 3 by 2 plus 1 by 2 into sine pi by 3 is root 3 by 2. So here we can say 2 root 3 plus 1 root 3, that is 3 root 3 divided by 4. So 3 root 3 upon 4 is the required answer, so which is option D. Area bounded by the curve y is equal to sin x. And the ordinates x is equal to 0 and x is equal to pi by 2. So we can see this is a half of the one closed curve, and we know that in short we can say one closed cup is nothing but 2 units measure, so it is nothing but half of the cups of 1 unit. 1 square unit, you can go with an option D. Directly we can say, but let us solve it. So area is equal to integral 0 to pi by 2 sin x dx, which is equal to cos x minus cos x over the limit 0 to pi by 2. So minus cos pi by 2 minus cos 0 minus 1 minus cos 0. So cos pi by 2 is 0, and again cos 0 value is 1. So 1 is the answer, so option C. Area bounded by the curve y is equal to tan x. So we can see the tan x graph. In 0 to y is equal to 0, that is x axis, and x is equal to pi by 4. X is equal to pi by 4, so we can write the shaded region will be below the curve and above x axis, that is y is equal to 0. So we can write the required area is equal to integral 0 to pi by 4 tan x dx. So integration of tan x log mod of secant x over the limit 0 to pi by 4. So we can write log secant pi by 4 minus log secant 0. So log secant pi by 4 is 1 upon root 2. So secant pi by 4 is root 2. Cos pi by 4 is 1 by root 2. Minus log secant 0 is 1. So log 1 is 0. So we can write log of root 2, or we can write log 2 to the power 1 by 2, that is 1 upon 2 log 2. So log 2 upon 2 square units is the required area, which is option B. The area of the region bounded by the curve y is equal to x mod x, the x-axis, and the ordinates x is equal to 1 and x is equal to minus 1. So y is equal to x mod x, we can write it as x square when x is positive and negative x square when x is less than 0. So we can sketch the graph. For x square, and for negative numbers it will be negative x square. And here origin 0 comma 0, say this is 1 and here minus 1, and with respect to x axis and the ordinates x is equal to 1 and x is equal to minus 1, the region bounded can be shaded, and we can observe that these two shaded regions are symmetrical to each other. So we can consider the required area is equal to 2 times integral 0 to 1 x square dx, that is 2 times x to the power of 3 upon 3 over the limit 0 to 1. So that is 2 into 1 upon 3 minus 2 into 0 upon 3. So which is 2 by 3 square units. So 2 upon 3 square units is option C is the answer. Area of triangle formed by the line x plus y is equal to 3. So we can get x upon 3 plus y upon 3 is equal to 1. So we can see that x intercept is 3 units and y intercept is 3 units. So we get a line and now angular bisectors of pair of straight lines. Pair of straight lines can be taken here x square minus y square plus 2y is equal to 1 and minus 1 is equal to 0, or we can write x square minus of y minus 1 whole square is equal to 0. So which implies x square is equal to y minus 1 whole square, or x is equal to plus or minus 1 of y minus 1, or this can also be written x minus 0 upon root 1 is equal to plus or minus y minus 1 upon root of plus 1, which is in the form of bisector equations of the two lines x is equal to 0 or x minus 0 is equal to 0 and y minus 1 equals to 0. So x is equal to 0 and y is equal to 1 are the bisectors of this pair of straight lines. So x is equal to 0 is a vertical line, but that is y axis, and y is equal to 1 is a parallel to x axis. So let us consider the line just drawn parallel to x axis, that is y is equal to 1, and when y is equal to 1, substituting here we get x is equal to 2. So we get the point, so x is equal to 2, so 2 comma 1. So we have 2 units here, and since this point is 1, so 0 comma 1, so here 2 units. So the area formed by the bisectors and the pair of straight lines, bisectors of the pair of straight lines, and x plus y is equal to 3 is the region formed here, and so required area is equal to half into the base is 2 units and the height is 2 units, so we can say 2 square units. So 2 square units is the answer, which is option A. We need to find the area between the parabola y is equal to x square. So y is equal to x square is a parabola open upwards, and if the line y is equal to x, the line y is equal to x will meet. So the area between them is the shaded region. Let us find the point of intersection. So one point is clearly 0 comma 0. So solving y is equal to x and y is equal to x square. So we have x square is equal to x, or we can write x square minus x is equal to 0, or x times of x minus 1 equals to 0. So we can write x is equal to 0 or x is equal to 1. So here we can consider x coordinate is 1. When x coordinate is 1, y coordinate is also 1. So here is a point 1 comma 1. So the required area is equal to integral 0 to 1. The upper curve is y is equal to x dx minus the lower curve is x square dx. So we can write x square upon 2 minus x power 3 upon 3 over the limits 0 to 1. That is 1 by 2 minus 1 by 3 minus 0. So that is 3 minus 2 1 upon 6 square units. So 1 by 6 square units is the answer, which is option A. The area between the curve y is equal to 1 minus mod x and the x-axis is equal to. So 1 minus mod x we can write 1 minus plus x when x is positive and 1 minus 1 plus x when x is negative. So we can see the graph. One minus x means when x is equal to 0 it is 1 unit, and when x is equal to 0 and x is equal to 1 you will get 0. So we will be getting the line for x is greater than or equals to 0. So we need to draw the graph, and again for when x is less than 0 we can say 1 plus, when x is equal to negative 1 it is 0, and when x is equal to, so we will be getting the graph. And the area between the curve and x-axis can be given by this triangular region. So let us consider this point is A, B, and say this is C. So required area is equal to area of triangle ABC. We can say half into, so here the total length is 1 plus 1 2 units and the height is 1 unit. So half into 2 into 1, so we can say 1 square units. So we can go with an option A, 1 square unit is the answer. The area of the figure bounded by the curve y is equal to e to the power of x and y is equal to e to the power negative x and x is equal to 1. Let's see the graph. E power x we can consider when x is equal to 0, e power 0 is 1, and when x is equal to 1, e power 1 will be 1.7. When x is equal to minus 1, 1 upon e is a decimal fraction value. So we get the graph of e power x is, so this is e power x graph, and now y is equal to e power negative x graph. When x is equal to 0 it is again 1, but when x is equal to minus plus 1 it is 1 upon e fraction, and when x is equal to negative 1 it will be e. So you will be getting the graph. So this is y is equal to e power negative x graph, and now and between x-axis, between these two curves and x is equal to 1, so here we can say x is equal to 1 line. So the region formed between these two curves and x-axis x is equal to 1 is here. So that can be given by required area is equal to integral 0 to 1 upper curve, that is e to the power of x, minus the lower curve is e power minus x dx. That is e power x, integration of e power x is e power x minus integration of negative e power negative x is minus e power negative x plus x over the limit 0 to 1. So we can write e power 1 plus e to the power of minus 1 and sub lower limit e to the power of 0 plus e to the power of 0. That is e plus 1 upon e minus e power 0 is 1, 1 plus 1 is 2. So e plus 1 upon e minus 2 is the answer, which is option B. Option B is the answer. The area of the region bounded by y is equal to mod of x minus 1 and y is equal to 1. So mod of x minus 1 we can write x minus 1 when x is greater than or equals to 1, negative of x minus 1, that is 1 minus x when x is smaller than 1. So we can see the graph. X minus 1 at x is equal to 1, we can say the y value is 0, and when x is equal to 2, 2 minus 1, 1, means you are getting the graph. This is how the graph can be taken, x minus 1, and 1 minus x is a negative slope. So we can see the graph. So in this direction, that is negative of x minus 1 or 1 minus x graph. And y is equal to 1, we can see y is equal to 1. By substituting y is equal to 1 here, when x is equal to 0, y is equal to mod of 0 minus 1, which is equal to 1. So here we can see that the graph, it cuts at the point 0 comma 1, and also when y is equal to 1 here, x coordinate can be taken as here 2.2 you will get. So 1 comma 2, when y is equal to 1, we have y is equal to x minus 1, so 1 is equal to x minus 1, so x is equal to 2. So 1 comma 2 is another point, and hence the area of the region bounded by the line y is equal to 1 and mod of x minus 1 is here, is a triangular region. We can say this point is A, B and C. So the required area is equal to half into area of triangle ABC. So area of triangle ABC, I can use it directly, half into base into height. So from B to C, the length is total 2 units and the height we can see this is 1 unit. So half into 2 into 1, which is 1 square unit. So we can go with an option B. Option B is the answer. Thank you.